Okay, well, let's start things off. First off, welcome and thank you very much for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fisher Technic Education Division here at Studica. And today, what we're going to do is we're going to take a look at the newest release in the Fisher Technic line of simulation models, that being the Agile Production Simulation, also known as APS. Now, this new model is designed to demonstrate how the current challenges faced in production and logistics planning can be addressed, and it is designed to incorporate the best features of previous Fisher Technic models, along with many new cutting-edge innovations. So before we dive into the meat of the presentation, I'm just going to provide you with a bit of background on Fisher Technic and its products. Now, the model we're examining today is once again the newest addition to the Fisher Technic line of industrial simulation and training models. And these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. Now, the line of Fisher Technic simulation models essentially consists of a series of pre-assembled small-scale models, which are designed to replicate in both appearance and function various automated robotic machines and systems that are commonly found in commercial manufacturing. The Fisher Technic company has been creating tools for teaching students of all ages about how technology works for almost 60 years now, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, Fisher Technic was created with more of an engineering mindset. And what I mean by that is that the core building block in the system is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts used in the system are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will help technical builders to address very specific design needs. The Fisher Technic system itself was created back in the 1960s by German inventor Arthur Fisher, who you see on the screen now, and he's noted for countless innovations used in both the construction and the automotive industries. Now, at the time of his death in 2016, Mr. Fisher held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating Fisher Technic, Mr. Fisher was first noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. Everybody's used them. His company, the Fisher Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, many people are familiar with Fisher Technic's line of construction sets, as I touched upon, and the focus of these building sets, whether it's those intended for the retail market or those that are intended for classroom use, has again always been on helping to foster an understanding of technology. The sets designed for use in the educational sector are most often focused on a specific subject area that falls under the umbrella of what is now considered STEM education. So, because of this, you'll have sets addressing topic areas such as mechanics, pneumatics, robotics, renewable energies, and so on. Now, typically, students would use these sets in the classroom and they'd be asked to build a progression of different models, each using the unique Fisher Technic building system, and then they would perform various experiments which allow them to explore and understand key aspects of the particular subject being studied. Now, the line of Fisher Technic simulation solutions, which is, of course, the model we're going to be looking at today, comes from that line, are something much different. The line consists again not of kits, but of a series of pre-assembled small-scale models which are designed again to replicate in appearance and function various automated robotics machines and systems. Models in the Fisher Technic simulation line would include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fisher Technic also offers numerous variations of an integrated factory simulation model. And in the case of these factory models, they usually consist of four or more individual workstations, most commonly something like a vacuum gripper robot, the high bay warehouse, a multi-processing station with an oven, and a sorting line with color detection. And these models are all designed to work together as one self-contained material cycle. Other variations of this factory focus on the idea of Factory 4.0, which utilizes IoT in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing each of these models in detail, I'm not going to touch on them here, but I would strongly urge anyone who's interested to attend an upcoming presentation if you'd like to know more. Or, of course, you can also reach out to me directly for any more information, and I will, of course, provide details on how to do that at the very end of the presentation. Now, before we begin our overview of the new Agile Production Simulation model, I'm going to very briefly outline some of the advantages of using these Fisher-Technic simulation models. First, Fisher-Technic simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible and physical system to observe and work within the programming or PLC-focused learning environment. The models are once again designed to realistically replicate in both appearance and function common automated systems. And again, these are things like conveyor belts, sorting machines, robotic arms, and so on. Because of their compact size, they're not only ideal for use in the classroom or in-office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and a very important one, is quality. Each Fisher-Technic simulation model is a hand-assembled, high-quality German-made product. The majority of the models in the Fisher-Technic simulation line, including, of course, the Agile Production Simulation model, which we will look at today, are designed as 24-volt models, which were designed specifically for use with the latest industry standard PLCs. Now, while the APS model that we're going to be looking at today already includes all the PLCs and all the necessary components within the scope of delivery, there are other Fisher-Technic 24-volt models that are available where you can choose to control them with the PLC of your choice, as well as the programming language which you might prefer. Again, these models are designed specifically for use in higher education, lab settings, and industrial training facilities, and so on. So that's why you're going to have the focus on 24-volt models. Finally, Fisher-Technic simulation solutions are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll pretty quickly notice that the entry point for many of these products can be quite high, especially something as advanced as the APS model we're going to be looking at. Fisher-Technic simulation solutions, on the other hand, start off at just a fraction of that price. And again, they're compact, realistic, and high-quality learning and demonstration tools. And while admittedly the new APS model is on the higher end of the Fisher-Technic product line, it still offers significant value in terms of what it allows you to address for still what is a very reasonable price point. And you'd be likely hard-pressed to find a truly comparable solution currently available at any price. So with that being said, let's now dive into our discussion specifically on the Agile Production Simulation model and discussing what the term Agile Production means and why this concept is important. So here's a slide that I've used in several of the other Fisher-Technic webinars that we present, and this basically shows an early version of the Henry Ford style production line model. Now, the Ford production line was in its own time a very innovative thing, of course, in that it streamlined production back at a time when the focus was on efficiently producing a large quantity of the exact same thing. Now, in this case, of course, workers along the assembly line each focused only on a very specific part of the automobile production process. For example, maybe someone had focused specifically on installing one specific component or making a certain adjustment before the vehicle was moved further along the production line, where, of course, the next worker in line would perform their specific task that they're charged with, and so on and so forth, until, of course, the assembly of each model was completed. Again, when the goal was to produce a large quantity of the same thing, this kind of method worked quite well. Of course, things are no longer quite so simple, and with good reason. Product customization must be considered, as well as the large number of assemblies and components that need to be used in the process. Likewise, the increase in customization options which are available. Product life cycles are also much shorter now, with an increase in overlapping product launches and production mixes. And flexible manufacturing requires an increase in logistics processes. So to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex processes. Now, this requires companies to better synchronize production and logistics, to make investments in cutting-edge automation equipment and processes, and to be as efficient as possible. As an example, consider the production of a modern automobile, such as the BMW 3 Series, which is shown here. Now, the manufacturing process must be set up to efficiently and cost-effectively address the 18 different engine options available to consumers, as well as the 5 different equipment packages and 70 different individual equipment options. Now, clearly, the old school Henry Ford style assembly line, which again was designed to quickly produce a high quantity of a single specific model, simply will not work anymore. And it's with this in mind that industry has increasingly transitioned from the assembly line production method that we looked at back there, with its rigidity and constraints, to methods such as the matrix production model, which eliminates the fixed time cycle and sequence of processes, or fluid production models, which also allow for an unlimited number of assembly scopes per station. The most notable benefits of incorporating such agile production methods are in the area of flexibility, including the increased flexibility in production processes, being able to offer customers specific mass production while avoiding overcapacity, and also reducing lead time through a mix of different derivatives. An additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. And this is why Fisher-Technic created the new Agile Production Simulation model, which again is the latest version of the Fisher-Technic factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI. In addition, this innovative new model also includes a digital learning platform. Here's a very quick look at the full factory model. Now, as we've just seen, forward-thinking companies rely on automation, modularity, artificial intelligence, and agility to remain competitive. Now, in order to promote these topics in industry and research, students, apprentices, and employees each require the corresponding know-how and awareness to enable them to deal with these complex issues. And this is where the Fisher-Technic Agile Production Simulation model comes in. Again, it's designed to simulate processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and to replicate automated processes on a small scale, from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the Fisher-Technic simulation line, including an automated guided vehicle and a 6-axis robot. The accompanying didactic materials are designed to help to translate the hands-on simulated processes into future skills for both students and teachers. In addition, the digital twin of the model helps to significantly intensify the learning experience. Now, as we're still awaiting the release of a fully narrated video for the factory, I'm going to provide you with a brief overview of each of the workstations or modules in the factory, beginning with the section where incoming and outgoing goods are placed. Now, this is, of course, where the material flow of a workpiece would begin and end. In this station, the raw material is delivered at the goods receipt slot, positioned on the color sensor for quality control using the 6-axis robotic arm with a vacuum gripper, and it's then encoded on the NFC reader. The 6-axis robot then places the workpiece on the automated guided vehicle, or AGV, for further transport. You, of course, see the model here. This module also contains the central control unit, which is a Raspberry Pi, and the environmental sensor, which measures the different environmental conditions on the factory. There's also an integrated movable camera, which can be swiveled in two axes and provides an insight into the entire factory via the Fisher Technic cloud-based dashboard, which we saw examples of in our previous factory. Well, no, we didn't. I'm sorry. At the end of a cycle, a finished workpiece is delivered back to the goods dispatch of the AGV. Now, the next stop for a workpiece after a goods receipt is usually the high bay warehouse. And although because this is an agile production simulation, of course, the order of processes could be changed if there was a need for doing so. But in any case, the high bay warehouse contains 9 slots for workpieces. It includes a stacker crane and a vacuum gripper that picks up the workpiece from the AGV at the docking station and hands it over to the stacker crane for storage. The workpiece is placed in a workpiece carrier for storage, and the retrieval of each piece is done according to the first in, first out principle. The next module we might encounter would be the drilling station. The drilling station consists of a docking station for the AGV, a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the drilling head. After a simulated drilling process takes place, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places the object back onto the AGV. This would bring us to the milling station. On a side note, as I have not yet mentioned it before in our presentation, you will note that the high bay warehouse, the drilling station, the milling station, and the station for ingoing and outgoing workpieces, and the next station we're going to look at as well, will each come pre-wired to a Siemens S7 1200 PLC, which has been pre-programmed, just like the one you see on the screen now. I just want to mention this for now, but we'll, of course, touch on it a bit later in the presentation. Now, continuing along, the milling station consists of a docking station for the AGV, and again, it has a vacuum gripper, specifically with this station, that places the workpiece onto a conveyor belt from where it is transported under the milling machine. There, of course, a simulated milling process occurs where 2 pockets are supposedly milled into the piece. And after this process takes place, the workpiece is again placed back onto a conveyor belt and transported back to the gripper arm. And the gripper arm again places the workpiece back onto the automated vehicle for its next stop. Next up is the quality control with AI module. In the quality control module, a vacuum gripper places the workpiece on a conveyor belt. It's transported underneath the camera and it gets scanned there. The workpieces, which come in 3 different colors, red, white, and blue, also have 3 machining features put onto each piece, whether it's a drilling feature, milling, or drilling and milling, as well as various fault patterns that are put on each piece. And these pieces are classified using the trained AI. Now, depending upon the color of the piece, the feature that's represented on the piece, or any fault pattern that may exist, the work pieces are then either placed back onto the AGV vehicle as being okay and acceptable, or they're sent to the reject container as being not okay or defective. And just to provide a little more information on the AGV itself, it is, of course, a module which transports the work pieces from one module to another. It's controlled by a Fisher Technic Robotics TXT 4.0 controller, which has been pre-programmed using Python. The AGV is essentially a track-bound vehicle that follows the printed black tracks found on the factory floor. It uses ultrasonic sensors to detect obstacles that may be in its way. The vehicle has omni wheels, which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle dock to individual factory models. The AGV receives its driving commands from the central control unit, which is an industry standard VDE 5050, and it uses a Fisher Technic rechargeable battery pack as its power supply. And last but not least is the charging station. When the battery of the AGV runs low, it navigates towards the charging dock where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station connect the AGV with the charging electronics. Moving right along, let's just quickly review some of the technical specifications. You have a 24 volt power supply unit, 11 amps. Central control is again the Raspberry Pi 4B. Individual modules are controlled with the help of 5 SPS Siemens S7 1200 PLCs. Additionally, the model includes 3 Fisher Technics TXT 4.0 controllers, which are used to control the sensors and camera, as well as to facilitate cloud access in the WEWA module for quality assurance with AI, as well as for the automated guided vehicles. And there's a WLAN router for the WLAN network. Software used on the APS model includes SPS programs, structured text for the PLCs. There are TypeScript for central control of the Raspberry Pi. There's Node-RED for communication between SPS and the Fisher-Technic TXT 4.0 controller. There's Python for programs on the TXT 4.0 controllers. And there's TensorFlow for supervised learning and quality assurance with AI. Additionally, like the most recent versions of the Fisher-Technic Training Factory discussed in our other webinar, the APS model has a cloud-based dashboard which can be used for order control and monitoring of the factory status, as well as for determining key figures. The factory itself can be broken down into sections which utilize an easy-to-put-together tongue-and-groove assembly method like giant puzzle pieces. Now, when assembled, the Agile Production Simulation model has a footprint of approximately 51 by 73 inches, and it has a total weight of approximately 116 pounds. A storage case is available separately for protecting the model when not in use or when being transported, and we, of course, will look at that very shortly. And again, didactic materials are also included in the scope of delivery. Now, as I mentioned earlier in the presentation, we're still awaiting the completion of a narrated video of the factory in motion, but while that isn't available, I would like to share with you this raw video we have of the factory in operation. Now, you're going to see it essentially go through the motion of the various steps I touched upon earlier. Again, you can see that the AGV moves along the black track that's on the bottom of the factory floor. It has Omni wheels again, which allow it to move in whatever direction it needs to for the processes, depending on the order. The camera that, of course, monitors the factory, which you can view from the web-based dashboard. The environmental sensor, tracking things like the temperature, the air quality, etc. This is, of course, the station where the workpiece is entered into the process and also where it ends up when everything is said and done. NFC chips, of course, on the workpieces. You see it has the 6-axis robotic arm that moves the workpiece to the AGV for transport to wherever the first workstation is for it. Again, in this case, it seems to be the high bay warehouse, where again there's a vacuum gripper that is attached to the high bay warehouse. Transports the workpiece to where it can be put into the carrier tray to be stored in the warehouse slots. And again, retrieved as needed, first in, first out. Again, the dashboard tracks the work pieces that are in the warehouse. If a piece needs to be ordered, let's say by a customer, or if you need to, move materials around, that can all be done from the web-based dashboard. Again, a piece can be retrieved and used, and by the vacuum gripper arm, it's put back into the AGV. The AGV would then take the workpiece to the next station where it's going to be worked on. And again, this process will continue with the various stations where the various processes are conducted on the workpiece as it moves on to a conveyor. Again, many of these stations will have their own conveyor section. In this case, you have a drilling process or you have a milling process that goes on or what have you, depending on the station. You have the Siemens S7 1200s that are attached to each individual work module. Again, this is the quality control with AI module here. This is again where the pieces are scanned and determined to be whether they be quality pieces or if they're defective pieces. That one is on the screen there, and then it gets, of course, weeded out. And the piece is delivered, and the vehicle goes back for recharging. And there you go. And that shows you how the factory comes apart. So another very important aspect of the APS model, which I touched upon earlier, is the inclusion of a digital learning platform. The digital learning platform is a high-performance, immersive learning environment, and it's based on a digital twin of the Agile Production Simulation. Now, this serves as the educational counterpart to the physical factory model. This learning tool is used to clearly illustrate the control units, the actuators, and sensors included on the model, and to demonstrate the full functionality of the APS. The platform offers interactive learning modules on agile manufacturing, IoT, AI, and automation. It enables the simulation and evaluation of a highly complex process workflows in agile manufacturing. The digital learning platform is a byproduct of the partnership between Fisher Technic GmbH and the Karlsruhe Institute of Technology, the prestigious public research university located in Karlsruhe, Germany. And please note that there are no additional costs or fees associated with this platform. It is included in the scope of delivery when you purchase the APS model. Now, to give you a better idea, this page helps to illustrate the structure of what is covered by the digital learning platform. Now, as you can see here, users start with an introduction to the Agile Production Simulation. This begins with an interactive explanation of each of the process modules, as well as of the control units, actuators, and sensors. Following this, the main instruction is broken up into 4 separate modules, one focused on agile manufacturing, the second on the Internet of Things or IoT, the third on artificial intelligence, and the last on automation. Each unit or learning module includes the following: a theory section, establishing a fundamental understanding of the topic at hand. 2, a practice section. This is where users can simulate and understand the processes being studied with both the physical mode and the digital twin version. And 3, transferability, where students get to see how the knowledge they've acquired can be used in the real world. Now, here are some screen captures of the digital learning platform to provide a better idea of just what it's all about. The digital twin forms the foundation for the digital learning platform. Once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules. The digital twin can be used to simulate complex challenges in an agile production environment. Just kind of click through here. And again, these are screen captures.
There are 4 different learning modules. Agile Production.
Somebody's talking there over me. Okay. You will see that there are a lot of tools with the DLP, including the Workflow Planner tool. and an analysis tool as well. Now, if you want to delve further into this, you can do so easily by simply emailing me, and I will provide my contact info at the end of the presentation. And then I will be happy to send you a link to the specific section of the manufacturer's website where more detailed information and system requirements are posted. Flexible, modular, agile, and connected. This is the Fisher-Technic Agile Production Simulation model. The APS model is the perfect tool to use in higher education, for advanced CTE training, university labs, and for industrial training. It's an ideal tool for teaching about the future of production, and it offers a hands-on learning experience. It provides a safe method for teaching these skills while also offering a tool that replicates, again, both in appearance and in function, those which will be used in industry. It provides a bird's eye view of working factory, and of course, it offers a considerable added value with the digital learning platform. It's also ideal for demonstration purposes for companies involved in areas such as IT and software development, as well as consulting. In addition to the APS factory itself, there are now two add-on modules which can also be incorporated if one wishes to expand the functionality of the model. The additional annealing furnace production module unlocks more learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available. These cover topics such as introducing new derivatives into production and expanding existing production configurations within a additional process. The module, like most of the modules of the APS, includes its own Siemens S7 1200 PLC, which has been pre-programmed in structured text. As an FYI, the annealing furnace module has dimensions of approximately 22.5 by 15 by 9 inches, and it has a weight of approximately 10 pounds. It is, of course, designed specifically for use in combination with the APS model and is not designed as a freestanding workstation. The second add-on available for purchase, as I touched upon earlier, is an additional AGV, which can also be added to your model. Now, like the annealing furnace, the add-on automated guided vehicle also unlocks access to further learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available. And these focus on agile intralogistics, as well as the parallelization and prioritization of production workflow. The model ships with a pre-programmed Fisher-Technic Robotics TXT 4.0 controller, and as with the version included in the APS, again, the programming is in Python. This can, of course, only be used in combination with the APS model, and again, is not intended for freestanding use. Just for reference, the dimensions of this model are approximately 10 by 7 by 5.5 inches, and it has a weight of about 3.15 pounds. And that concludes the main portion of our overview of the Fisher-Technic Agile Production Simulation model. Now we're going to look at the cost for each of these items. The basic factory of the Agile Production Simulation, which again includes 5 Siemens S7 1200 PLCs, and 3 Fisher-Technic TXT 4.0 controllers. And as well, it also includes access to the digital learning platform with the digital twin. The cost for this model, all inclusive, is $28,174.95. I will mention as I get into these pricing, this is all, of course, pre-tariff, what have you. Right now, we are going to hold the line on things until something forces a change, but at this point, knock on wood, this is where we're going to hopefully stay at least for a little bit. The add-on modules. The annealing furnace includes, again, the Siemens S7 1200 PLC pre-wired to the model. It unlocks additional didactic content, again, in the digital learning platform, and the cost for this module is $3,859.95. The additional automated guided vehicle, the AGV, again, which also unlocks additional didactic content in the digital learning platform, has a cost of $2,249.95 per unit. As I touched on, the Agile Production Simulation storage case. This is a two-tier aluminum case with foam inlays to protect the individual workstation modules. If you're familiar with our previous presentation where we talk about the factory simulation models I touched on before, those are one-tier cases. So this is a special two-tier case. We'll flip through some slides of it. The case itself, this is basically, since, of course, the APS model is such a substantial investment, this is really an important thing to help protect the model when it's not in use, and of course, if you're going to need to transport it safely. The case itself has an aluminum case maker profile with plastic plates. Each of the two separate case sections has steel tilt handles and angle protection corners for additional stability. Now, there are also straps and internal zipper pockets for storing cables, cords, workpieces, and other accessories. The lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules while in storage. As you see there, the dimensions of the case are approximately 48 inches by 32 by 29 inches, and it has a weight of approximately 75 pounds unloaded. And when the APS model is loaded into the case, the total weight is approximately 190 pounds. Please note that even when the model is kept in the storage case, if you are transporting the model, we suggest that it always be shipped flat, and we also suggest that it's always shipped as freight on a pallet. And the cost for the storage case is $4,024.95. So at this point, if you did have any questions, you could use the Zoom chat window or the question window, both of which can be found on the Zoom toolbar on the presentation. If I don't see anything pop up, I will say this. If you'd like to take the next step, for example, if you would like to request the full color 2025 Fisher Technic Higher Education and Industry Guide, which features the APS model, if you'd like to request a quote, if you'd like to speak with your dedicated educational representative, depending on which state you're in, or anything else, you can call us directly. Our number here in the US is 888-561-7521. If you have general inquiries, you just want to get a quote, some general information on Fisher Technic, you can email us at info@studica.com. Or if you would like to contact me directly for anything that I discussed today, or anything else you'd like to find out about this model, other Fisher Technic simulation models, or any of the Fisher Technic products, you can, of course, email me directly. And again, my email is lance.zurek, lance.zurek @studica.com. So on that note, I'd like to thank you again for taking the time to attend today's presentation. We look forward to hearing from you soon, and I hope you have a great day. Take care.